Figure 8.4, ThisTest.java. The purpose of this example is to introduce the keyword this, which you can use both implicitly and explicitly in the non-static member functions or methods of your class definitions. Now, if you look carefully at this source code file for a moment, you'll notice that we actually have two class definitions in the source code file. We have a public class called ThisTest, which contains our main method to test the program, and we also have a class called SimpleTime that is not preceded by the public keyword. First of all, remember that every public class must be defined in Java inside of a file that's got the exact same name as that public class, including capitalization, and the .java extension. So the name of this file has to be ThisTest.java, and you can see over here in my Project Explorer that indeed the name of the file is ThisTest.java. This is a non-public class, or what is known more properly as a package access class. Classes that have package access basically are available to other classes in the same package, but if that package were to be wrapped up and given to somebody else to reuse, the users of that package would only be able to see the public classes, not the non-public or package access classes. So basically what's going to happen when I compile this program is that I will indeed get two different .class files, one for the ThisTest class and one for class SimpleTime. They will both be placed in the same directory, which is also considered to be the same package, and therefore class ThisTest will be able to use class SimpleTime. Now let's take a look at class SimpleTime first. It's a shortened version of the time1 class that we were looking at before. Actually, it's got a little bit different functionality as well. And if you take a look, we still have three private integers representing the hour, minute, and second. And take a look at line 23 in particular, because this is a common problem or programming error that some people wind up doing. Here we've implemented the parameter names to have the exact same names as our instance variables. And you may recall an earlier example on scope where we showed you that when a local variable, parameters are local variables, when a local variable has the same exact name as an instance variable, the instance variable is shadowed or hidden inside the scope where the local variable exists. However, there is a way to get around that and still access the instance variables, and that's what we're demonstrating here on lines 25 through 27. Here we're explicitly using the so-called this reference to access the hour instance variable of the current object of class SimpleTime that we're manipulating and assign it the parameter value hour. So the way the compiler looks at this expression is when it sees the name hour by itself with no qualification, it assumes that means the parameter hour. And when it says this dot hour, it knows that we're talking about the instance variable hour. So this says take the parameter hours value and assign it to the instance variable hour, take the parameter minutes value and assign it to the instance variable minute, and take the second parameters value and assign it to the instance variable second. In fact, in all the prior classes that we've been manipulating, every single time we've used an instance variable inside of the many different methods we've defined of our classes, the compiler was automatically inserting this dot implicitly in front of each of those instance variable names. Now that actually gives you a couple of other interesting capabilities. When you are in a tool like NetBeans and you type this dot, it is smart enough to pop open a window showing you everything that can go on the right side of that dot, such as all of the instance variables, our build string method, and our toUniversalString method. The things that show up in bold here in NetBeans indicate items that are defined directly in your class. The ones that show up in plain text indicate items that were inherited into your class, in this case the members of class object, because all classes implicitly or explicitly are going to extend from another class, and if you don't say what class to extend, you get the object class for free and all of its members for free. So when you use this dot, you get an additional benefit inside your development tools to help you with your programming. If you're just using a normal text editor, then you'll get no specific benefit out of using this explicitly unless you're doing a scenario like what you see here, where you're using the same parameter names to your methods as you have instance variable names in your class. So this is one case in which you will commonly see this reference get used. I personally prefer not to use the same names for my parameters and my instance variables, therefore I don't have any confusion, but a lot of programmers do like to implement their code for constructors the way you see here. We also have a build string method in this class, which we're going to use to output, or not to output, but to create a string containing information about the current time. And the format control string that you see here is going to output a string in a field of 24 right justified, followed by another string, and then a new line character, and then a string in a field of 24 right justified, another string, and that will be the total string that we're returning. The first piece that we're going to output is the string, this.toUniversal string, and then we're going to output or format the result of the this.toUniversal string method call. Down here on line 35, we're going to add in the string toUniversal string, and then we're going to add in the result of the call to toUniversal string. Now both of these method calls, this.toUniversal string and toUniversal string by itself, are doing the exact same thing. They're both calling the toUniversal string method down here at line 39 for whatever current object of class SimpleTime is being manipulated. In fact, when I do line 35's call to toUniversal string, the compiler is implicitly adding this dot in front of that method name. So when you invoke one of your own class's methods from another method of the class, unless it's a static method, the compiler is going to implicitly insert this dot in front of the method name. When you're calling static methods, remember that you normally need to precede those with the name of the class and a dot. So we're going to call the same toUniversal string method twice, once with an explicit use of the this reference and once with an implicit use of the this reference, and then toUniversal string is going to give me the 24-hour clock format string for the time. And notice once again that I've explicitly used this dot hour, this dot minute, and this dot second. In the scope of the toUniversal string method, this dot is not required because there are no local variables that have the same names as my instance variables, so I could just as easily have removed each of the this dot notations that you see on line 45 as we had done in our prior toUniversal string example. So going back up to the top of this program, in main, in the ThisTest class, we simply create an object of class SimpleTime, passing some initializers to the constructor, and then we invoke time.buildString to show you that both ways of calling the toUniversal string method result in the same output value. And when we run this program, we can see in the program's output here that in both cases, whether we use the this reference or not, we get the exact same result. So just summarizing, the this reference is specifically for use in non-static methods of your class. Static methods don't have access to the this reference. The this reference actually refers to the specific object that you're currently manipulating. So when I say here at line 9, time.buildString, the object I'm manipulating is time, so this is a reference to the time object. If I had another object called time2 and I invoked one of the methods on the time2 object, then this would be a reference to the time2 object instead. Right, so that's one key thing, and then the other key thing again is that the non-static member functions of your class can either implicitly or explicitly use the this reference to access other non-static members of the class, whether they be data or other methods, both of which we showed you in this example.
Looking to advance your career by acquiring new skills? Tired of expensive off-site training programs? Wish you could learn from the best instructors in the industry? Look no further than live lessons. Self-paced, personal video instruction by the world's leading technology publishers. Each live lesson comes with a DVD featuring 3 to 4 hours of instructor-led classroom training, sample program code that allows you to work along with your personal instructor, and an example-rich study guide. Live lessons allow you to watch the entire course from start to finish, or navigate directly to any of the individual lessons. You'll literally watch over the shoulder of your instructor as he shows you how to build state-of-the-art applications. Live lessons, the power of the world's leading technology experts at your fingertips. To learn more, visit mylivelessons.com today.